All right, the recording has started. Hello, everyone. Thank you for joining us today. Today, we're coming together to learn more about Azure Cognitive Services using Python. In today's session, we are continuing this journey with Microsoft Learn Student Ambassadors. And in today's session, we're exploring the Microsoft Azure Cognitive Services and how they can be integrated with Python-based applications. We learn how to use services such as computer vision, QnA Maker, speech service, and much more. And this session is aimed at all those who are interested to utilize the Azure Cognitive Services in their Python applications. The session today is with Vijaya. Actually, let me have that slide. Yeah, Vijaya is a recent graduate of BITS Pilani Dubai campus and is a Microsoft Learn student ambassador in the UAE. She's currently a graduate student studying computer science at the University of Massachusetts, and she's interested in artificial intelligence and healthcare. Her area of interest is in research, medical image analysis using machine learning with the aim of assisting healthcare professionals. You know me by now. I'm gonna skip this very quickly. This is Hassan from Microsoft Reactor, and you know Microsoft Reactors are hubs for founders and developers all over the world, where developers and startups can meet and learn and explore the various technology and the recent advancements. And it's also the home to the Microsoft for Startups program. So make sure that you're checking our calendar for more events like today's session. And I would highly encourage you to be mindful of others. And this is the code of contact to just be friendly to everyone, engage with us on chat. And we're coming from different backgrounds. So please make this a friendly place for everyone. Um, I think that's all for now. We will start the session. I'm going to hand over to Vijaya to start today's session. Thank you, Vijaya, for joining us. You're on mute. Can you update the settings, please?
Can everybody see my screen right now?
Yeah, we can see the screen and you're audible.
Hi guys, so as Husam introduced me, I'm Vijaya. So I'm currently a master's student at the University of Massachusetts Amherst. So I'm interested in machine learning and AI in general, and currently specialize in trying to apply machine learning on medical images. So it has like a very good it has a very good social impact, as well as it's a very interesting field in my opinion. It's like a very cross domain field which combines medicine plus computer science plus even ethics actually with regards to the safety of handling medical data. So yeah, that's what I'm interested in. So let's start this session with our main topic today. This is our agenda for today. So I'll be giving a short introduction to what is machine learning, and I'll be introducing you to a very popular machine learning model called linear regression. We will be talking about the prerequisites for this session today, and in this session we'll be using Azure ML Designer, which is a very easy, simple to use drag and drop tool to create ML pipelines. And I'll also be giving you a short introduction to Azure ML in general. And we'll be having a live demo in which I show you live how to use Azure ML Studio Designer, pardon me. And from what we do in the demo, we'll actually understand what we've learned using the tool, and I'll point you and I'll actually help you guys find really good resources for building on top of what we learned today. And I'll be giving you I'll be giving you extra references as well. And then finally, we'll have a short Q&A session if so that we can actually answer any of your doubts. So let's start off with introduction to machine learning. So, broadly speaking, machine learning comprises a set of mathematical and computer models and algorithms which learn by experience. So, to be more specific, I'm going to use Tom Mitchell's definition, which says a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T as measured by P improves with experience E. So I can break this down to you like in a very simple manner. Suppose you have a model that classifies between cats and dogs. It's like a very popular example to actually give. So your computer model is that program, and after feeding it like tons of data of cats and of images of cats and dogs, it starts to actually classify the any given image into a cat or dog. So the task is classifying cats and dogs, and for performance measure, we usually take accuracy, like how accurate your okay, is the image a cat? 100% right. But if your model labels the image as a cat but it's a dog, it's wrong. It's like 0% accurate. So with training time, machine models will actually like these computer machine models will actually improve. So machine learning can be roughly divided into three main categories: supervised learning, unsupervised learning, and reinforcement learning. So if you can see screen right now, you have different types of tasks associated with the which each model. So with supervised learning, we have classification, regression, and before I get into the details, I'll just quickly briefly explain what is each type. So in supervised learning, you have data, but you know what the results should be. You know the output. For example, if I have thousand images of cats and thousand images of dogs, I know that the first group of images are cats, and the second sets of images are like dogs. So it's labeled. So I have a label to associate with each training instance or training data. So, however, in unsupervised learning, we don't know what our output is actually. We only have a collection of data that we've observed. So we can do some quite useful things with this data, and some of them are like dimension reduction and clustering. And the third type of machine learning, which is quite recently getting popular, is reinforcement learning. So this is like quite commonly seen in game AI and robot navigation tasks. So we can see that machine learning has so many applications in real life, as shown in the image. So we can have image classification. As I said, I work on medical image data. So I've used machine learning to classify between tumorous and non-tumorous medical images. So this is like very popular application of machine learning in healthcare. Another very common task that you see is weather forecasting or financial trend prediction, what's the prediction that the stock can go up or down in like 1 week's time or 2 weeks time or next year. And we also have clustering, where you can find similar groups of data given the observable points. And of course, I think we many of us actually play video games. So I think we've seen game AI while playing games, how the enemy reacts to your movement and all. So these like some of the very broad applications of machine learning. So machine learning is not as simple as like feeding in data into your model and expecting a result to come out. There are like several steps to machine learning, and one of the most important steps I would say in machine learning is not actually training the model, but actually preparing your data for that. So usually the data that we get is very messy. It's very unclean, so we have to do a lot of transformations to it. So we have to transform it, we have to normalize the data to like certain range. We have to clean the data of wrong values or unknown values or empty values. And then after we have this clean data, then we can pass it to the model. And once we finish training our model, we can reiterate we can reiterate the training by changing the learning rate. We can change different parameters of the model. And the number of parameters will of course depend upon what model you're taking. Some models have less parameters to like choose and pick and to fine tune. Some models very large neural networks have like lots of hyperparameters to tune. So hyperparameter tuning in itself is a huge resource topic. And of course, after we usually we don't feed the entire data to the model at first. After we clean the data, we usually split the data into training and test, or like training, validation, and testing, depending on what use case you're training for. So we actually train the model on the training set, And then depending on how and if you want to evaluate our model, like how well does it perform, we then test our model using the testing data. And after this, we can after we train and test our models and we see and we're satisfied with the result, we can deploy the model. So today we'll be working with the ML Designer interface, and we'll be using the linear regression model. So a linear regression model can be simply thought of as finding the best fitting line given your a set of points. So for example, in this 2D version of the linear regression problem, we can say that we have all these observed data points. We can say, for example, the x-axis over here says maybe it's the height of a person, and then we can estimate maybe their weight, because based on the height of a person, we can actually we can actually loosely predict how much a person can weigh. Like the x-axis can be the height in centimeters or meters, and the y-axis can be the predicted weight of a person. So you, okay, of course, all since humans are different, different builds, different sizes, female, male, different statures and like muscle mass, you're going to get a variety of a varied amount of data, like all these blue points are observed data points. So but we want to find the best fitting line. So once we get the best fitting line, if I query a point, let's say I want to find a possible weight of a person, if they're 1.5 meters, I can just plot the point on the x-axis and find the corresponding point on the y-axis and say, okay, fine, this is the predicted weight of the person. So our simple linear regression formula is quite simple. It's y is equal to b0 plus b1 x1. So b1, b2, bn are the weights of the model corresponding to the variables that you're testing on. For example, in our case, we only have one variable, that is the height. I mean the height of the person. So x1 will correspond to the height, and b1 is the associated weight. So when we train a linear regression model, we're trying to find the best fitting B1, B0 and B1. And of course, if you have more variables like, height, age, gender, you will get quite a lot of variables fit on. So the data which we will be using in this session is the automobile data set, and it'll be using multiple linear regression model because as we can see, with cars and automobiles in general, there are a variety of factors actually. So this is like a small overview of the linear regression model. So for our session today, you will need to have an Azure account. And the best part about this thing is that an Azure account is free. So you get 12 months of popular free services, and you also get $200 to spend on like the much more premium services. And you can create a free Azure account at this link below, https azure.microsoft.com/free en-us/free. So once you create an account, you can easily start working with ML services, cognitive services, and all the other amazing Azure products and services Microsoft is offering you. So yeah, let's get to the live demo. So this is one run that I have plotted. We'll be doing the same thing right now, but this is how the ML designer looks like. So I'm going to my home. So once you create a Microsoft Azure account, you'll be directed to the portal. And in the portal, you can actually manage all your resources. You can find how much money you have to spend on on different services. You have a variety of resource groups and very popular Azure services over here. So right now we'll create a resource for our ML. So I can easily find it over here in AI plus machine learning, and you can see it over here, machine learning. Let's create a resource. I'll create a new one. Let's say Reactor demo, and I can say Reactor demo workspace as my workspace. So now Azure will check if you can actually create the resource. If it's clashing with anything, it'll inform us. Validation passed. So now we can create our resource. Great. So our resources has been deployed. We can go back. All resources. There we go. React demo. Oh, good resource. There we go. And so once the resource loads, we can we're directed to this resource page, and over here we can see that we can launch our machine learning studio. So we have plenty of options over here. We can create notebooks using Python. We can create automated ML models. And here we'll be actually working on our working on this during our session, which is a designer, which is a drag and drop interface for prepping for creating ML pipelines. So it takes care of from the data point till the deployment point. So it's like an end-to-end pipeline system. And we create a
Vijaya,
new
just a
pipeline.
quick one. I'm noticing some feedback on the screen. So if you can zoom into the content during the demo, that will be great.
Oh, sure, definitely. So you
And for anyone who's facing any issue streaming the content or anything, we're recording this one, so you will be able to come back to it. No worries. But yeah, going forward, please, zoom in a little bit.
So
Thank
just
you.
like reiterate if people haven't seen it. So once the resource has been created, you get a link to which will redirect you to this page like of your new resource. And usually for the machine learning resource, you'll be able to there'll be a button called Launch Studio. It will direct you to this place to the Microsoft Azure machine learning page, and you have a couple of options over here. But we'll be doing the designer portion, and we create a new pipeline. So this is our workspace where we can like drag and drop items. So before we do anything, we should actually create a compute target. A compute target is basically like, on which machine are we going to like run this code on. So we'll select a compute target. And just for this assignment, we will create a new one. Let's call it reactor demo compute. So it'll give us a machine that has like 7 gigabytes of RAM and 8 gigabytes storage. Oh, this is too long. Okay, I'll just name it reactor demo comp. Oh, it's fine. Save. So this is going to create right now. So in the meantime, we can start on our pipeline. So we have a couple of sample datasets over here that we can easily use, like create like small models. Otherwise, you can also like import your own models and import your own datasets and use them as well. So we'll be using the automobile price data dataset, and we can see how it looks like. So as you can see, as I mentioned previously, this has many variables, and our predictor is going to be our price. We're going to try to predict the price of the automobile given all these parameters. But if you notice one thing, can everybody see my screen? Like I think it's like a very important point. I'll just zoom in a bit more, if possible. So if we can see over here, the normalized losses column has a lot of empty values, nans, like the unknown values, so in machine learning, having these values is actually quite bad, and it can like it can either affect your calculation really badly, or it's going to like crash your system entirely. So we should probably remove this. So we'll be doing that. So we have our dataset right now here. We can go to the data transformation section, and we can do select columns. We can select the specific columns that we want, and we can ignore that normalized losses column. So one thing you can notice in the ML designer interface is that we have these small nodes. So how we create the pipeline is we drag we drag a node to the next node. So we want our data set to go from here to into this function that is selecting columns in the data set. And we'll be editing the columns over here. So we want all the columns except for normalized losses. So let's include all columns, but let's add an additional, additional condition. We can add an additional condition using this. So we're adding with rules, but we want to exclude one column name that is normalized losses because it has those NaN values. Say, and now, but I think we have, since we're removing the NaN values, removing the column, we still want to clean our data set just to be like sure about it. So we can do that by finding the clean data set node, clean missing data. We'll join this node to this node. And now we have the clean test dataset in this node. The other node gives us a transformation, but for now we don't want the transformation. We only want to work with the clean dataset. And as I mentioned before, we don't usually feed in all the data at once. We need to like split our data into a certain ratio so we can use a large amount of it for training, but we still have more data remaining so it can be on which we can test our model. So let's do that by finding the split data node. Here we go. Let's take the data set, feed it into this node. So I'll take, so there's like a couple of heuristics in which you can actually choose the ratio. I'm going for 0.7, like 70% training and 30% testing. And you can randomize the order in which these rows are selected by just entering a random seed. So the first node will give us the first data set, that is the training. And the second node will give us the evaluation/testing data set. So now we're able to choose our model actually. So let's find a machine under machine learning algorithms. We can find linear regression, what we've learned right now. So I'll just put it over here. For clean missing data, I need to clean the data. One moment. So let's clean all our columns, just make sure it's all cleaned up. Let's save. Perfect. Now we have the model. Now we should train our model actually before we do anything else. It's very important. So here is the train model. Now train model has two nodes again. It has the untrained model where you feed in the model like what we're going to use, and that's linear regression. And we have which dataset are we training it on? Our training dataset. And now it's asking us for the label column. As we said, we actually want to predict the price of the automobile. We click save. And now after we train our model, we have to score it, how well it's actually performing. So we can scroll down, find score model over here. And now we'll be using our testing data for scoring it. And finally, we have to evaluate the model with our metrics, which is usually a loss function. And that's it. Through a simple interface, we can actually create a pretty good machine learning pipeline. So I think our compute cluster has been created. Yes, it's been created. So we can select existing compute cluster, save it, and we can submit. Let's create an experiment. Let's just say it's taking out automobile price, and we can submit it. And we'll see that our pipeline is running, and we will be getting a result soon. So we click here, run details. And this is like the same version or the same model that we've created. And we can see that it's actually running in real time. So right now it's preparing the linear regression model and it's queued up. So this might take a bit of time depending on like which compute machine you're using. But in the end, you should get something like similar to this, in which you have successful run, which is completed. And we can see over here. Pardon me one second. So if you want to see how well our model is performed, we can right click on a score model, and we can visualize the score data set. So these are the predictions. So since you can see the floating point numbers, these are our predictions. So it looks good. There are no missing values. And let's see how well our model performed by visualizing our evaluate. And we can see these are our values for our metrics. So mean absolute error, root mean square error, relative squared error, and relative absolute error. And these are coefficient determination. Having these values closer to 0 is actually much better. But having this value close to 1 is like a good metric. So as we can see, it's above 0.5. We can see that the model is actually learning, and it's like since it's above 0.5, it's actually like going towards the right path. But we can actually improve this through changing the model maybe from linear regression to like a neural network if maybe, because if we have more data, a neural network can actually perform better, I would say. As a general heuristic, it's not always the case, but just like a general heuristic, if you have lots of data, a neural network is actually very effective in like learning features. So yes, so this is our output. Has our run completed? Okay, it's still running though. So as this model is running, does anybody in the chat have any questions?
For everyone who's with us on today's session, feel free to keep asking questions during the session and use the meeting chat for that. Yeah, we got a question from Jay.
Go ahead, Jay.
So do you want to read the question, or by the way, for any community member who wants to engage on audio, by the way, you can mention that to me on the chat, and then when we stop to cover the question, I can enable that feature for you.
Could you like read the question to me, Hussam? I don't think I can see the comments while sharing.
Okay, so Jay is asking, did you remove the records with the normalized losses or replace the values with something to keep these records?
Oh no, we completely removed the column. So we so at the I can show it to you. So at this step, the select columns in data set. If you check our rules, one moment. So as you can see, we've completely removed the normalized losses. So before it was the symboling. So if you saw the previous data set, I'll show you the original one. So this is our original data set. It has symboling, normalized losses, make, fuel type, aspiration, number of doors. But after the operation, that is select columns in database, in which my rule was to select all, include all the columns, but exclude normalized losses. We can see that we've completely ignored, we've dropped the entire column, essentially. We haven't replaced it. So I think the confusion is coming in the next step, that's clean missing data. Basically, I've dropped the column in that in the table. However, just to be sure there are no missing values apart from the normalized losses, I'm running it through the clean missing data in case there's like any like missing value in general. A nan is I think it's a different from an empty value. So if you can check the clean data set, you can make sure that there is at least some value in the in the list in the entry. Sorry about that. So does it answer your question, Jay? Or should I repeat it one more time? As you can see now, after some time, it's actually running. So this node is running, so this node is not running. I believe this will take some time actually. So it's like a large data set. But you can see that actually our runtime is actually going in like a proper flow actually, like one node after the other. Any more questions in the chat, Husam?
Jay says, thanks so much, all good. So yeah, there are no more questions. But yeah, I highly encourage everyone, if you have questions now, since this is processing, maybe we can take some more questions while this is getting ready. And if you prefer to talk and use the audio, please let me know on the chat. I will enable that feature for you. I think there is one more question coming from Muhammad. He's typing right now. All right, so Muhammad is asking, can we use the ML Studio to process images, or are we better off using computer or custom vision for these cases?
So you can use both actually, because I'm pretty sure, like I think just by as you might have seen, like when I was scrolling down the nodes, there is like our trained model on images, image data, and all. So the things with custom vision, as far as I know, you can use both your own custom models as well as the Microsoft specific ones. So yes, you can use both 100%. But I wouldn't say one is better than the other, simply because I think these two are like totally separate services. So you can try like both the ML designer as well as the custom vision service, and see which one better integrates with your application. And more specifically, I would say ML designer is more like like more better for like pipeline work. If it's more like have like a quick application with like vision services, I would say to go with custom vision. Oh look, some of our notes are completed. That's nice. So in the meantime, as this thing is running, I'll just like give you a bit more like a couple of links in which you can actually like learn more about machine learning and Microsoft Azure. So at the end of the session, you learn what is machine learning, as I've explained before. What is linear regression, as we can as we've seen. What is Microsoft Azure? Like it's like a cloud computing platform and the services provided by Microsoft. We've learned what Microsoft Azure ML is. We have a number of things we can do with it. We have Python. We can do Python notebooks. We have the ML designer. Uh, pardon me. And then we've seen what is the Azure ML designer. It's like this tool which you can like quickly drag and drop and create ML pipelines, and how to use it. Like I just quickly showed you guys a demo. We're still waiting on the results. It will take a bit of time actually when computing the actual like pipeline. So in the meantime, where should we go from here? So I would recommend all of you to go check out the Microsoft Learn Azure ML um, Microsoft Learn module. It's quite informative. It will go into more detail about using Python. It'll go into detail using the QnA module, custom vision, and all the good stuff. And you can also check out if you want to go get into more image related topics like me, like who's very interested in image processing and medical image data, or even like any kind of image/video data. I recommend that you also try out this module called classify images using custom vision. So you can check out these. I'll keep this slide on for 2 minutes if you want quickly type it in your browser and check it out.
So we got these links, by the way, earlier posted in the chat, so you can also scroll up and use these. I'm gonna paste them again, actually, for convenience. So here you got it.
And if you want to get into a bit more detail of what I did today, you can also check out the documentation on the official documentation page of Microsoft. You can easily find these online by just even Googling them. So we have the Azure ML documentation, we have the Azure ML Designer documentation, and we also have the demo tutorial. Let's check out if whether our module has finished computing. Oh, it's almost done. We're at the training step. That's nice. Almost there. And after you finish your experiment you run, you can even go ahead and publish it to the cloud. And what I like most about the Microsoft Azure machine learning, services, that you can quickly prototype, and you can quickly create pipelines. You can quickly incorporate intelligence in machine learning into your application, whether it's a desktop application, a mobile application, or even like a general experimentation as well. So it's a great way to learn machine learning. Oh wow, it's done training as well. We're almost at the end. Come on, we can do this. And not in the graph, you have like a couple of other tabs like steps over here. So the same steps that you have in the nodes, like the automobile price, the cleaning, the splitting, the training, the scoring. You can see that there's the same steps that are represented over here. You also have the outputs and logs over here in case you want to check out if there's any errors, or uh, or you got logging functionality you can implement. Great. Let's see. Oh, it's done almost. As you can see, it's the scored model as shown previously. So for example, so we can interpret it as this. Sorry about my browser. It's so we can say, let's say for an audio on gas using turbo 2 hashback, the price is 23,712. I'm not sure about the currency, but it's quite a high value in general. So we can see all our car prices, scored labels, and then our evaluator is running. It's in the final step, that is finalizing the results. Oh wow. So once your pipeline is done training and through all the nodes, you will get a notification on top. And now we can see, similar to what we saw in the previous demo, that we have a mean absolute error, root mean square error, relative error. So these should be actually closer to 0. I think you will get better results if you normalize the data in the beginning of the step, which we haven't done. And of course, okay, in this run, it's actually the coefficient determination is actually quite less, which is kind of not good actually, but it again depends on how you're splitting the data. For example, in this run, I split the data, I believe 0.8 or 0.75 actually. I believe it's 0.75 parameters. Yeah, 0.75. In the previous, and I use a different randomization seed. So based on a different number, you will get a different different randomization. So I think this randomization and this fraction of row training data actually perform better than this one, in which we have taken 0.7 and in a different seed. So in our case, no, one of our parameters is like how much of the data you're going to split, like 70%, 75%, 80%. So you have to see which model works best for you. Thank you guys so much. So this is the ending of our session today. So hope you guys learned something new with the Azure ML Designer. The floor is open to any questions. Feel free to ask anything.
Thank you, Vijay, for joining us today and sharing your experience with our community members. Yeah, the floor is open for more questions. We still got some time. And if you want to engage in chat or audio, we're happy to have that enabled for you. Just type in the chat and I will enable audio for you. The session is recorded and will be available later on our YouTube channel, along with the rest of the student global series that we have had. Okay, I'm gonna share meanwhile some links to resources and things for you to do after the session. Including, for example, the Reactor newsletter sign-up. So basically, this is for you to receive a monthly curated email with all the interesting happenings across the reactors. Now that we're doing our sessions online, you can be attending sessions across the world. So that is something interesting that you don't want to be missing. So yeah, there's a question from Mohammed saying, how do you take the trained model and put it into the production environment?
So you can do that by publishing it actually, and you can like create an endpoint for that. I believe the links that Hussam and I have sent have those steps involved.
Beautiful. All right, so yeah, I highly encourage everyone who's watching us live or later on YouTube to check out the links that we're sharing that are related to few learn modules and paths. These will help you continue the journey after today's session and keep learning. All right, I think that's all good for today. I'm just gonna share one more thing here in the chat. So we are officially 3,000 members here in the Meetup Abu Dhabi community of the reactors. And yeah, great milestone, and it's been a very interesting journey since we started. We hosted so many different speakers over different topics, and I'm sharing here with you a very quick survey for us to understand also topics that you would love to see, timings of the day that you prefer to have these sessions. Everything we're doing, we're recording it. So in case you had any other commitment and you couldn't join us live, you can always tune into the YouTube channel and watch it there. But joining live allows you to get the benefit of asking the questions to our speakers and get these answered. So yeah, feel free to subscribe to the Reactor YouTube channel, which I just posted the link in the chat. Thank you everyone for joining us today, and thank you Vijaya for
Thank you so much
joining
for
us.
having me.
It was a pleasure having you. Have a great rest of the day, everyone, and see you in the next one. Bye-bye.
Bye bye, guys.